So, um, climate change. Everybody has heard the phrase greenhouse effect, and most of us could say something about it. But when you try to explain how it actually works, the mechanism, step by step, it gets slippery fast. Let me build it up from the bottom. Start simple. The Earth sits in the cold, and the sun shines on it. Energy arrives as visible light, and the planet warms up. That part is easy. The interesting question is the other one. Why doesn't it just keep warming forever? Because it gives energy back. Anything warm glows. You are glowing right now in infrared. So the Earth radiates heat out into space, and it settles at whatever temperature makes the outgoing match the incoming. That balance is the whole story. Everything after it is detail. Now, run the numbers for a bare rock with no air. You get about minus 18 degrees Celsius. The real surface sits near plus 15. So something holds back 33 degrees worth of warmth, and that something is the atmosphere. Here it gets molecular. Most of the air is nitrogen and oxygen, two identical atoms stuck together, perfectly symmetric. Infrared goes straight through them. They just don't grip it. But a molecule with three or more atoms, carbon dioxide, water vapor, methane, can bend and stretch lopsidedly, and that wobble catches infrared. Quick correction, because I had this wrong for years. It does not work like an actual greenhouse. A greenhouse stays warm because the glass stops warm air from floating away. The atmosphere doesn't do that. The name is just a bad name that stuck. So, well, what happens when you add more carbon dioxide? This is the piece that usually gets left out, and it is the heart of it. Heat does not escape to space from the ground. It escapes high up, from the altitude where the air has thinned out enough to let infrared through. Add more carbon dioxide, and that escape altitude moves higher. Higher means colder. Colder things radiate less. So for a while, less energy leaves than arrives, and everything underneath warms until the books balance again. That is the mechanism. Right. Where is the extra gas coming from? Carbon that was locked underground. Coal, oil, and gas are ancient sunlight, plants and plankton buried for hundreds of millions of years. We are digging it up and burning it in 2 centuries. Add cement making, add cutting down forests. But how do we know it's ours? Because the carbon is signed. Fossil carbon is so old that its radioactive carbon-14 has completely decayed away, and living plants prefer the lighter carbon-13. So as we burn, the isotope mix in the air shifts in exactly the predicted direction. There is a second signature. Burning consumes oxygen, and atmospheric oxygen is measurably falling, by about the amount the burning accounts for. That is hard to explain any other way. The numbers then. Before industrialization, roughly 280 parts per million. This year, the average is around 430. Ice cores look back 800,000 years, and it never once climbed above about 300. And the temperature? Near 1.4 degrees above the 1850s. That sounds small. It isn't. The whole distance between today and the last ice age is only about 5 degrees. Then the feedbacks, and honestly, they matter more than the carbon dioxide itself. Warmer air holds more water vapor, and water vapor is a greenhouse gas too, which roughly doubles the effect. Melting ice uncovers dark ocean that soaks up more sunlight. And clouds do something. Clouds are still the biggest open question in the field. A few things that get repeated and are not right. It isn't the sun. Solar output has been flat, if anything slightly down, since the 1980s, while the warming sped up. It isn't volcanoes. We emit something like 100 times more. And the trace gas objection fails too. Trace amounts of ozone are the only reason you are not sunburnt to death. There is also a line of evidence with nothing to do with thermometers. The ocean has swallowed roughly a quarter of the carbon dioxide we released, and it has become measurably more acidic. That happens whether or not you trust a temperature record. So, what is, honestly still uncertain? How much warming a doubling of carbon dioxide finally delivers, near 3 degrees. But the range is real. How the clouds respond, whether the ice sheets have thresholds we cannot walk back from. Those are open. The mechanism is not. If I had to leave you with one picture, it's a bathtub. The tap is running hard and the drain is tiny. The carbon dioxide we add today is still up there in 1,000 years. So the number that matters isn't the level in the tub, it's how far you turn the tap.